AI. This is a tricky subject for me. I've been trying to learn a bit more about it. Um, but yeah, I looked over again Liquidfire projects, see how he did it. And I think I prefer more of a Final Fantasy 12 Gambit type system where I just have a whole load of different priority lists. Well, one priority list with a load of actions set in them, and then the AI will just pick from the best option, really, or just pick the option as it comes along. So I think I'll just get coding and I'll try and explain things as I go. But there'll be an overall ability picker, um, but there's going to be a behavior which is you'll have a behavior class, and that will decide what is the list of priorities. So if a unit is completely fine, 100% health, no status effects, then it could have a very aggressive pattern, which is try and get close to the foe, use melee attacks, use your spells, whatever. But then once that unit's health drops below, say, 25%, you could replace the attack pattern with something that's more conservative, trying to heal itself, trying to get away from the enemy. So that's behavior. And then, yeah, pattern will just be the list of priorities, and each priority should have some kind of target, some kind of condition, and the action it wants to use. So condition can be, are there 3 or more enemies surrounding me? Is my health below a certain percentage? All that sort of thing. And the way I'd like it to work is to go to the first item in the list and then search every movement position to see what the best option is for that ability. If it finds any way of using it, then that will be a good thing and it will try and use it. If it finds no available target, it will move on to the next object or next item in the priority list and then do the same thing, try and find something to hit. If it can't find anything, then I will try and do some kind of movement that is maybe based on this. It says if I am a melee type, then I will always try and get close to a foe. If I'm a range type, I will try and keep my distance, but not too far away that you can't attack next turn at least. If it's support, probably stay close to allies. I think this one could be scrapped. We'll just save that for flee/panic, get away from the foes. Yep, like I say, I'll just get coding. We'll see where we get to, or if it all crumbles and breaks. Let's see. What do we have? We've got enemies here. Probably have some kind of ability picker on this, and then have the behavior on this as well. Let's yeah, get some code down. See the way it pans out. Enemy behavior, just to be a bit more specific about what we're trying to do here. Okay, so on here, there's going to be list of list of patterns. So we'll make this abstract. I think. Do we want this to be? So how does this work? Let me see. So there'll be a list of patterns and conditions. Maybe make a common folder here. These are all files from when I tried out the liquid fire attempt. And then also some from my previous AI attempt that I just scrapped as well. So let's check out. So I've got AI pattern here. So enemy behavior. Decide which pattern to use. So there'll be some kind of condition here. Uh, um, so there'll be maybe choose AI pattern, and then this will go through a list of AI patterns, check the conditions attached to them, and see if one of them is valid. I guess on here there would be some kind of pattern, private AI pattern, and that just then So this will be a way for um, of setting the active pattern. I don't know if this is a good way of doing it, since it's not really relative to it's not relevant to all units. Should maybe be its own little script that I just grab if I know I'm working with an enemy. Or maybe that should be on the enemy behavior itself. So when we choose an AI pattern, check each condition, then set active AI pattern. Um, if we have the pattern object already, can't we just put the condition on here and then have a public bool is condition met? We'll return false for now, but obviously that'll change. So this is each AI pattern will hold the condition. This should be behavior condition. And then in here we can just look through the list of patterns, private list, AI pattern, AI pattern list. If the behavior condition is met, we can just return early after setting the active pattern. There should be some kind of default pattern here. This could just pick from the pattern list, but I think it might be better to just have its own specific default, because then you don't need to make the default part of the list if you don't want it to. Maybe you want the default to be something, just run up and hit them with a sword or whatever, but you don't want that to be part of your regular pattern. Then that's a way of doing it. So set active bomb. So I guess that's the basis, the skeleton for choosing a behavior down. Of course, we're not actually checking any condition yet. We don't know how to do anything like that. AI condition. Yeah, I think this is probably good if it's abstract and we'll build on top of it. So we'll have an abstract bool of is met. Um, Probably going to need some kind of parameters in here. Maybe the person, uh, the parent unit should be on here maybe. Um, Maybe the thing that they're targeting, whether that's themselves or someone else. This probably shouldn't be abstract if we're just gonna drag and drop some options into it. So there's AI pattern, behavior condition. So what kind of conditions do we have? We'll have stat conditions, we'll have um, units within radius or units within range condition. Um, Status effect condition, if you're inflicted with certain type of status effect. Um, I think I'll pass on that for now. So we've got an AI pattern, but what do we not have? We don't have the ability picker yet, which I think this technically is that AI pattern. Let's make ability picker. Um, am I being limiting here by having this enemy only? If one of our player units is confused or mind controlled, then they will probably need some kind of ability picker. And they wouldn't have a pattern either. Mm, what is this bit? How do we bring that into it? I guess this, instead of this being the overall object that picks, the ability picker could be the middle part. This could have the, no. It's the pattern. The pattern should have a list of ability target conditions. So the AI should have some sort of public void pick and the ability picker will have some sort of public void pick. So is it on here I would have the list of this? Yeah, I guess the hierarchy or the architecture isn't really solid in my mind on how it's going to work. I was thinking the ability picker would be at the top, and all we really care about with this is saying pick, and then it's going to choose one of the options somewhere else that we've set up, probably within the pattern. So ability picker will look at the active pattern, which is in here, and it will pick from these. Yeah, that makes sense. I guess I'll build it for enemy AI first of all, and then when it comes to adding in confuse and charm and things, I'll have a rethink and see how easily it can be adapted. Because if something gets charmed, then they won't have any behavior set up because it doesn't really make sense. The player can in some way develop a character to have a complete different set of skills to another player, possibly, depending on how a game is. If it's more like a traditional Final Fantasy, then as you level up, you gain skills. So it may be fairly set between different players. But if it's more like Final Fantasy Tactics, where you can just equip a piece of gear and learn a skill, one player's set of skills will be completely different from another player's set of skills. So you won't have a generic sort of enemy behavior for each of the different units that a player has. So an enemy behavior suddenly turns into um, a player behavior, which maybe both of them would spawn off of some kind of base class, AI behavior, and then the enemy one will have a set pattern or a set way of dealing with how to pick what. And then the player behavior can be more dynamic. It will pull from a list of skills it will maybe have some hierarchy of what skills are good and what skills are less good. And then maybe it can pick based off that. So yeah, I'll just keep going with enemy behavior fully separate. We'll have public enemy behavior, get return get component, because this will be on the same level as enemy behavior, I think. So then pick can be enemy behavior dot active AI pattern dot pick, and then I don't know if we want to catch this somewhere or just send it off and use it somewhere, because this could simply be an ability and then we decide what to do with it after. But I guess it makes more sense if we um, you basically come with a plan of attack, is the way I've heard it be referred to. So if you have a class or an object that holds the ability we want to use, holds exactly the tile we want to use it on, and it also holds some sort of move location, as in if the move location is the same as the player's current position, it means we don't need to move. Just use the ability, and then afterwards we can choose to move closer to someone, further away from someone, stand still, whatever. Yeah, it makes more sense to have that object, gather everything up from here, and then just pass it back and then use that. So I'll follow a similar design to that. I'll just call it AI plan. How dare you? Okay, we'll get rid of that. Get rid of that. Um, so it's public. There will be some kind of ability that we want to use. Um, Maybe a move position. Maybe a target position as well then. So in ability picker, we will create that. Um, we'll pass back an AI plan. Pick will be AI plan. And we'll just create a new one like that and return it. Okay, I think it's coming together. So now we have the behavior and the picker, and then in here we will start slotting in AI patterns. I'll make just a single one first of all, and then build upon here. So aggressive AI pattern, and then just have a flee, just so I can see the different ones working together. just threw myself off there. Okay. So probably don't want AI pattern on that. Since it's the parent object, we'll put it here. Um, what else? What? Okay, so we've got some idea of a condition that needs to pass in order for this to become the active one. I'm kind of holding off doing this because the condition will play into each of the AI pattern options as well. Maybe I'll just call it AI option. Will be a mono behavior just so I can sort of drag and drop. Serialize field private. Now there's going to be some kind of condition. There's going to be some kind of target, which I think we might get away with just using target type. Because that is non-self ally foe. I've added tile here, which is essentially just targeting a spot on the floor. And all. And then private ability for what ability you want to use. So the pattern here is essentially a list of AI options. AI option list. And let's just see what that allows us to do. Alright, so let's just start adding the options. We've got a fire spell. Here we are. Condition, target type, and then the ability. So we can start filling this in. Maybe just have two of them. Poison. Fire. Poison. So obviously I've not got conditions in yet, but that's fine. Alright, so now we'll put in the, if you're trying to flee, try to blind the enemy as a safety mechanism, and then we'll try and heal at the worst case scenario when we're about to die. We'll try and heal ourselves. Okay, let's see. So there's no default pattern. Oh yeah, we need to actually add the options. So here we go. It's fire. It's poison. No, we don't have a pattern in this one. Paste, pin blind, and heal. This is probably bad having blind there. So it'll try and heal itself first. So you want that to be in the first. And then it will try and cast first aid on itself. So there we go, heal, first aid, fire, poison, and then the AI patterns. AI pattern list. I should probably just hard code these lists instead of, well, instead of having this here. And having drag and drop, because that gets kind of annoying. Yeah, it's a bit unreliable having to actually drag and drop these in, because if you start moving things around and things break, then suddenly you lose all your attachments and you need to redo it and that. So let's fix that. So AI option list is going to be property instead. We're going to get, so list of AI options. Create the list, return the list, and then do something in between. We're going to loop around for each of the children. And then we check the child for an AI option. If AI option does not equal to null, well, if AI option equals null, continue, otherwise add it to the list. So I chose to do it this way because you're checking each direct child of the object. So yeah, this is saying, look at this object, check if it has an AI option. Look at this object, check if it has an AI option. I avoided using get components and children just in the off chance we start adding more to this or it gets more complicated, and then you end up with maybe nested. I don't know why, but maybe you'd end up with something like that. And then this would then gather these two AI options, but also these two. So yeah. It's just being a little bit safer with what I'm grabbing. And then this as well, the AI pattern list should do the same thing. But yeah, I think this time we do want to just grab all, since it'll just go through all of these and grab the AI patterns. Maybe this is overkill. I guess time will tell. It's definitely a good option if you only want to check the children of the object itself. AI pattern list. So this is going to get ripped out of here. AI pattern list, get, um, get components, get components in children, and we'll just be lazy and push it to a list. We're going to cache this. Because we don't want to be accessing that every time. We just want to, yeah, we don't want to be running this every time we use this. So you just grab the result and then use the result itself. Okay, so it doesn't look like much changed, but we saved ourselves so much bother there. Some kind of default pattern. We will just rip that out and say that's the default, the aggressive one. Now the conditions, I've been back and forward on this. I kind of like having it. I kind of like having the drag and drop nature of this, being able to just build it really easily. But it does mean having a lot of different prefabs here that explain the conditions. So if you want HP is lower than 50%, that'll be one object. HP is lower than 25%, that'll be another object. HP lower than 10%, that'll be another object. So how would I build that as a condition? How would I build this in a script? So I have a base one that says, is the condition met? So any is there any commonality between these two things? I guess we'll need the person, yeah, the parent unit. We need the parent unit because we'll only be interested in allies that are within our movement and heal range. We'll only be interested in the foes which are in the 3 range of the parent unit. So I guess it's just the parent unit is the only commonality, which isn't so good. So it's probably going to be that's not even good wording for this, is it? AI condition. So I guess the unit can maybe just be grabbed by looking up the chain and saying, get the first unit you find. Um, so this behavior condition on here, we'll just go up to that to get the base unit, to get the base unit. Is there anything bad about doing that? We'll maybe just do it. So private unit parent unit get return get component in parent unit. So that'll run up every object until it finds something or finds nothing. And that means we can use the parent unit in the isMet. Let's make a subclass of AI condition. It'll be um, stat comparison AI condition. So this will be, is one stat some kind of operator to another stat, or not operator, what's the, it's the, well, I guess comparison. Is one stat comparison to the other stat, as in, is my current HP less than 50% than the max HP? And I guess that opens up the doors for funky abilities as well. You could have a condition where if the strength is higher than something, do something. It doesn't really matter though. Let's just get this stat comparison, and this is going to be AI condition. Get rid of this. Build the abstract class. Return false for now. Stat comparison, and then maybe a targets within target types within range AI condition. That's an AI condition. Implement start class. Return false again. So what does this need? Serialize field. Target type. And then we want maybe int of quantity, because we want to say, are there this many of that type of thing near me? So this could be for allies or enemies. You want to say, are there 3 foes around me? Are there 3 allies around me? So then we'll just do some checks here, and then the stat comparison is going to be something like field primary stat, private stat, yeah, secondary stat. Why does it jump away like that? It's like it tries to help you, then covers it up. Secondary stat. It's going to be some kind of comparison. Maybe comparison can be enum. Let's see. Can I do shit like that? Not like that. Identifier expected. Hmm. Okay. Equal to greater than, less than. To less than or equal to. Is not equal to. Is that them all? So we'll have some kind of comparison, some kind of value, and then also just a bool is percentage. So are we dealing with a flat number or a percentage? So we're definitely going to need whoever it is we're comparing with, right? So the target would have to be in here. And there may not be a target unit in specific, but I think we need to pass something through so that this can calculate. This maybe this is fine, because if we pass in myself as a unit, then we can figure out how many of these are around this unit. And I guess that can also be used for allies and foes. If there are a lot of allies around this unit, then we can maybe try and put them to sleep so our allies get a lot of hits in, or who knows. So that's the basis of that. Then you need to go back to this here, the prefabs. Now it gets kind of gross because we need to start actually building these these conditions. So we could say, probably don't want to do it inside So what would this one be? Something like that, HP. Stat comparison. So the primary stat will be HP, the secondary stat will be max HP. If it's less than, we'll maybe make it less than or equal to, and we will say it is a percentage. So there, that's our first condition. So the way I see this working is if we go back to the enemy, behavior condition. Right, so flee, if we want to start fleeing, there. He flees when, oh, uh, so that'll need to be spelled out. Okay, so that's fine. Um, okay, so flee when HP is less than or equal to 50% max HP. And then we're kind of doing the same thing for this, but with different conditions. So I'll duplicate that one. Say 25. Remember to set that. So we wanna heal if that, and we wanna use first aid if that. Um, and there could be an any condition, which is just at any point do it. That might be a good catch-all at the end of a priority list, so you actually do something. So I'll just copy this and then rename it. So we'll call it any AI condition. It's going to be no parameters because we just don't care. We will always return true. So this condition is fairly easy. We'll just say any. Did the script decide not to rename itself? Any AI condition, and then it screams at me. AI, we'll get rid of that. Add any. So I guess we wouldn't put that here because that would just break. Or it wouldn't break, it would just never leave the aggressive AI pattern. Even if you had less than 50% health, it just wouldn't matter. This would say any and it would continue to always be aggressive. So I guess I probably want a greater than. And I won't do greater than or equal to because that would make the less than or equal to a bit redundant. It would only be less than. So it's just if he's got greater than 50% health. He will be aggressive with 50% or more health. We will use poison anytime if it reaches that, and we will use fire if he's got greater than 50% max health. Although no, because that will also ensure we never use poison. There are a lot of ways to screw the AI by building it in a broken way. So if you decide to try and build something like this, just remember you probably need some kind of catch-all NA just in case nothing ever happens. You don't want the AI just to be standing around doing nothing. Um, but yeah, instead of poison, it could always just be melee attack, which is quite normal for a lot of enemies to just use a basic attack if there's nothing else it can possibly do. Oh, the Dragon Age Origins, I think, also did this system really, really well, where you can add tactics to your characters and just let it play out. Now let's just make one greater than. This is a really boring AI, but we'll just give it if it's greater than 75. So all this unit does is base its attack pattern off of how much health it has. Okay, so the wolf, if it has more than 50% health, it will be aggressive. If it has less than 50% health or equal to, it will start to flee. When it's aggressive, if it has more than 75% health, it'll use fire, and then it'll use poison any other time. But when it's fleeing and it has, basically as soon as it starts to flee, it will start to try and heal. If it goes less than or equal to 25% health, it will start using first aid. So the basis of that is done. All that matters now is to actually code up the conditions, and to try and check if it can actually use the ability. That's the rough part, because I need to start looking at every point it can move and then look at the range that of every point it can move. So this might be a nice segue to look at the pathfinding again. Pathfinding. If I can turn this into a job, it would be quite good. Maybe Grok can do that. Maybe if I just paste in the code and say, can you turn this into a working job in Unity? And then I can see how it would go about doing it. Because I'm not the best when it comes to the entities and jobs and stuff. Well, entities doesn't really have anything to do with jobs, but that's how I started finding out about jobs in Unity from using the entity component system. But yeah, all of this stuff that's sort of lots of while loops, lots of loops in general. If you can just whittle this down into a job and split it up over multiple processors, that would be an insane speed boost. Insane. I don't know, I don't even know if it's possible to split this up, because what I want to do involves having some sort of closed list that they all end up looking at. Well, let's just see. Let's just see what it says. We'll start with get targetable positions. Yep. Hmm. Yep, that's what I want. Let's go to necessary structs and job. Okay, so that's I'm already using v3int, which is quite nice. Parallel start job. Use native collections. Yep, I understand that. Create a parallel job. Move the core logic into a job. Used allocator. Yep. Used a wrapper to handle that. Okay. To use this, same way as your original method. Might not always be faster for small ranges or small grids, but then the parallel overhead, I would assume, isn't going to lag your game. But if you wanted to suddenly have abilities which have 100 range, maybe that would lag your game. But maybe the parallel job would stop the 100 from lagging your game. So I don't see too much of a negative for using it, even if we're using smaller grids. And we're also not using a simple grid because we're using the fucking 3D grid that isn't even set anywhere. It can just be any position. So I think that's fine. This is worrying. You may want to implement a multi-pass approach where new neighbors are added and processed in subsequent job schedules. Add initial neighbors. Neighbor buffer. Okay, at least it is trying to add neighbors. Okay. Yeah, I wonder if this just works or if I would add it and everything would break. Let's see what's the A star node that we have. Oh, we have quite a lot in here. Mm, I think I'll avoid this. I think there's no talk of the reversing the path and things. How do you get the path from this? It gets the neighbors and it adds them and it tries to go through them and it loops around, but what's result? Let's see, what's result? Job handle. Oh, result equals reachable. Oh yeah, because this doesn't need this isn't getting a path or anything. This is purely getting a list of reachable positions. So that's maybe not the worst. This is maybe good. Yeah, reachable. It's adding to that as it goes. Okay. Hmm. Let's try to find path as well. See what it says. See how different it looks. What am I doing? Can you do the same for the following? I would like this find path code to be done in a job to speed it up. Alright, we're using the parent's position instead, which is smart. No references. Parallel pathfinding. Using natives again. So this is the job. Execute. Um, yeah, okay. Not really liking it. Maybe it was my fault not being specific enough, but it looks like all of the code is now in one job, rather than each node being found um, in parallel. Okay. So, so the node itself is marked as closed instead of have. Oh, so how does every part of the how does every separate job know this part though? Let's see. You know, maybe this is one of the parts that you probably don't want to be put in a job anyway. The actual pathfinding part, like go from here to there, you probably want to do it in serials so you can get the nodes marked up with the different distances and etc. and find the shorter distance. But the things that are like just grab all of the positions within a certain distance, maybe that should be put into a job. Then again, I've not even tested. I may as well try and write the code the way I want. Um, yeah, write the code the way I want without using jobs. And then if you start to see some slowdown, then worry about the improving things, efficiency. Right, so screw it. Let's get back to what we were doing. Let's see. Condition is met. So the option here really has a lot to do. Um, what I'm thinking here is there should maybe be different levels of intelligence somewhere. So maybe the picker, the ability picker has some way of saying I know this wouldn't be the best option, but maybe I use it anyway. So let me just go through it anyway. So the AI option has to have some way of saying this is valid. Um, um, yeah, I guess is valid, and this will check the condition. Um, so what is the condition will hold the type as well. The condition will use the type. I don't think the type will be used on its own. So how would this work? Let me see. Because obviously there's condition is met, and then there's some kind of target unit. Um, Again, maybe target unit is the wrong thing here. It might be tile. Uh, yeah, maybe it's the target position that's the important thing here. So if we pass in this as the target position, is the condition met? I.e., are there lots of people around? Are there lots of yeah, like give me the errors. This is not what we want, but for now we'll just add it in. Okay, so it's gonna be v3i. This might all change again, but this is just my gut feeling says it should be an actual position rather than a unit being passed in. So from the position we can grab some kind of battle unit if there is one. We should be able to get the range. So why would this need to know a position if we're checking stats? Let's work it out. The ability picker has some kind of plan that it wants. The active AI pattern. This will return some kind of plan. So we're not doing anything with it yet. So let's start looping through. AI option list. But again, we don't want to be running that code every time we use this, so we will just cache it. AI option list equals this. AI option list. So what do we have now? It's an AI option. Let's make it lower though. And this has condition, a target type, and an ability. So who decides what we're targeting? Have I broken something? Jeez. What's going on?